All right. So what I'm going to do is I'm going to take you through a real world scenario that talks to some of the things that Sean has just presented. And I'm going to try and do it in as practical a way as possible. So I'm going to get started with this little diagram, and I'm going to grab a here and we can get going. All right. So to start framing this little piece of the presentation, I want to draw your attention to the student, the actual human being who rocks up at your institution and wants to develop their skills and start investing into the future. Now, the more that you think about students and the more that we work with them as we roll out and develop these systems, the more that we realize just how much data they actually generate. And so in this scenario, I'm going to just combine access control and interaction with access control through this sort of digital world that we've been talking about. And as a starting point, I don't want to talk about systems or tech. As a starting point, I just want to try and build a little bit of awareness of how much data students really do generate. So as a starting point, students with their student cards interact with doors on campuses. And there are a couple of things here. I'll go through them one at a time. But every time a student passes through an access point or a point where there's a little card reader, they register a tap, which is cool because already we can start recording how many times students tap on various doors and which doors they've opened. And so we've got an initial data set going just from the action of them touching on the card reader. But that data is not all that's there when a student taps on the card. What we also have is their location at that point of time. And so if you just paid a little bit more attention to your data set and you located your doors and you pinned those geographically on a map of your campus, you would then know based on taps what the location of that student was at any point in time. And that brings on this third dimension. This is time, not so much worried about location, but every time that we tap on a door and we record the time of that tap, we have a stamp that allows us to infer certain things. So just as a silly example, we would be able to drill into a student and say, look, if we decided that the front door of their residence was a reasonable measure of what time they're getting up in the morning, we would be able to, for a student, determine what their average wake-up time is every day, as a silly example. But then if we did that across the student universe, we would start to be able to get behavioral trends just on the basis of their interaction with the door. Then we would also be able to see, look, what are the frequencies at which students are accessing particular doors. So you put taps onto a time scale and all of a sudden we know which doors students use more than others, and we know how often they're going into particular doors, because remember, doors typically reflect venues. And so we can start to measure frequency and see how often they go into various rooms and start collecting data accordingly. I just heard my Teams ping, so I'm just making sure that I'm not going to lose track of anybody who picks on the chat window. Okay, Sean, can I ask you that if anybody does chat, I'm not going to watch it. Will you just unmute and interrupt me?
No problem.
All right, so the ability to know which doors a student has access to gives us the information I've spoken about to now. One interesting side effect is that we can actually map per student, if we have access to just the taps on the doors, we can map how they walk around in campus, what routes they typically take when they go to various venues. We can see, if you just profile, be able to see which particular venues or halls and stuff they went into, and you'd be able to visualize that on a map. And so just from tapping doors, we get quite a lot of data. Students generate, like there's a ton of data sitting there. If we chose to be a little bit cleverer, and in some situations we can be, we can even refine that data set. So there's a difference between a door and a lane. A door would let me into a venue. A lane would be a subset within a venue. And so if I was thinking about a library and I said the door at the library lets me into the library, the lanes might be which floors I've typically gone to. I know in the meal management space, which is mostly what I'm going to talk about in this demo, we're able to put multiple lanes inside of dining halls, and then also see and be able to see which lanes students prefer. And then, if you're just a little bit creative, you go and put different meals on different lanes, and you can start to profile how different meals perform, which are preferred, what students prefer to eat, and you can start learning about them in a bunch of different ways. And so lanes give me quite a lot of additional information. So in sort of the facilities management context, I can know which floor a particular student is in at any one time. Another thing that you can tell from lanes, which I'm going to address here under lectures as well, is you can tell how many people are in a particular location at a time just because of the data that students are generating through something as simple as access control. Then in terms of ITS owns quite a lot of data relating to students. So as an example, from ITS, we can know which residence they live in. We can get access to how they're funded and which timetable they're currently attached to. What will often happen in the higher education space is that students will be on different timetables at different periods during the year. So normal timetable when they're studying, but then they go onto exams. That might shift a little bit, and ITS typically has the data that allows us to do that. And so just from a student's perspective, there's already quite a large surface area of what we can know about students. This next pillar is, you can actually see, I tried to be clever, and I turned my little preferences shape into what hopefully you'll recognize as an iPhone. Students, if we can just get mobile-based access to students so that we can collect additional interaction from them, we can start to allow them to overlay our data set with their preferences. So one example in the meal management space would be to say, look, if we decide to put different meals on different lanes, so we put bacon and eggs and sausages and all the oily stuff for the Oompa Loompas like me, and that's what I want to eat every day. And then on the other lane, we go and put yogurt and, I don't know, strawberries. See, I don't really know much about healthy food. We put that in a different lane. Then we could allow students through mobile access to be able to indicate which lane they would prefer to use. And that gives us some really cool side effects, the ability to control our vendors, make sure that we're not over catering, make sure that we're not overspending, and all sorts of stuff that happens there. But there'll be enough of that in the demo that's coming. One of the additional side effects of collecting data is that you can start to see things that you never knew you could see before. So as an example, if I took a student in a lane in a meal hall, and all I did was one subtle change in my data, I went and said, look, on that meal hall for that particular lane, the average nutritional value of the meals that are served there are X. So in other words, a yogurt contributes X in terms of calories and calcium and all the various different vitamins, and fruit does the same. And we went and profiled it. If I knew then which lanes they'd tapped on and which preferences they had, I could get a really reasonably strong estimate of what kind of nutrition was going on there. And there is some fun stuff that we're talking about in the space where we potentially can link nutrition to academic performance, and also link lack of nutrition to interventions that essentially become assistive to the students. And so there's some cool stuff that we can do there. Quality I put here, I think this is a cool one. If I gave you an example in sort of the meal space, if we had 3 dining halls, each dining hall was owned by a different vendor, and I knew what student preferences were, it would take me 6 months and I would see student preferences in terms of meals in their voting, because students vote with their feet. So we would even be able to do quality assessments of the various vendors running the dining halls if we were able to connect students to their preferences. And I'll show you how we've been able to do that in a real life example. And then the last little blocky here, I'm really hoping that in real world education, the on-premises education anyway, that students are wanting to be in lectures. But if we just put doors on lecture halls and we collected taps linked to doors linked to lecture halls, we could start drawing some interesting correlations. And I think I've got that in here. Oh, there we go. We can draw some interesting correlations between how often they access the various lecture halls, added to their overlaid on their timetables, and then look at the door taps, and we could see whether or not there's real life correlations between lecture attendance and results, and the number of lectures attended can then be used for additional sort of student management functionality. So just from a basic access control point of view, with just the overlay of preferences, you can see there's an absolute stack of stuff that students are telling us by tapping a student card on a wall. This RT occupancy, it was supposed to be a room threshold. And basically what I was saying there is if you had a scenario where, for example, you wanted to limit occupancy in a particular venue, call it maybe for something like COVID compliance, then this is something that we would be able to control with this data set, because we'd know in detail what was happening in each one of the venues, because we can demarcate them with doors. So that's what that is. Okay, so the point of the slide was really to just kind of look at the student and just get everybody kind of aware of how much data students actually generate. And all I'm looking at is their access control. I'm not looking at any of the other data sources that you might have in your institution. And already I can get quite a rich surface area that I can then use. So the question then is, how do you use it? And so I took all my labels away and I've added another layer. So the first thing that we do is, and Sean alluded to this in his piece of the presentation, the first thing that we do is we put a platform in place that allows us to collect that data. So I'll show you an example of it in a minute, but basically what we're wanting to do is we're wanting to say, look, let's take students and let's put them somewhere where we intend developing a student data set. And so typically what we're doing, and we do it fairly often at the moment, is we go and we take students out of ITS and we put them in the platform. Then we go and take doors and lanes and lecture halls and all of those kinds of things, and we put them in the platform too. And then obviously all of the transactional data that gets generated by any of these sources, we go and put in here as well. So what we end up with is one central place where we've got access to the way that students are traveling around the university, which doors they're tapping, which meals they're eating, what their preferences are. We've got demographic information because of what we can get out of RTS. In some cases, we've taken other data out of here. So like we've looked at whether or not they're funded by NSFAS, or we've looked at whether or not, or which study programs they're on. We've taken things like whether or not they're day students or resident students or temporary students. We put them in the platform. And so we start to collect a really nice, robust set of data that's centralized that we can then use in really, really cool ways. I'm hoping to show you some of that in a minute. So the first step is to kind of get the platform in place. And then the next thing is to leverage what you can do next. And that's what this automation layer is all about. So the scenario that I'm going to take you through is the controlling of how students eat and what they can eat and when they can eat and how much they can eat and how often they can eat, and to overlay that with vendor data. And hopefully by the end of the demo, you'll have a really good idea of what's possible just off of a couple of simple data sets. So the data sets that I'm going to be going through is a student data set, tiny little bit of data from RTS, and then information from doors, lanes, and then potentially lecture halls and libraries and those kinds of things as well. So in a nutshell, this is the overarching architecture, the design, and the intention of the slide is to show you that students generate a lot of data. That data might be lying in various places, and if you can get it into a platform, you can do really cool stuff with it. That's the harbor tour. So Let me show you some examples. So you'll see at the top of my slide, I've got solution with this really geeky developer-y type / vibes going on here. And I've said start with students. So if you're going to look digital and you want to start unlocking digital in the campus environment, a great place to start is with the student record themselves. And it doesn't need to be a heavy record. It doesn't need to be everything with every possible data point considered. And you can start out with a really, really basic record. So what I've got here is I've got the data service, that platform. This is what you're looking at. And what I've brought in is some basic students, and you can see that they listed here. This can go up to hundreds and hundreds of thousands of records, no problem, but at least we've got a base data set going. This is a data set we typically would integrate with RTS, and we keep those two synchronized. What I want to point out just in terms of digital is that this thing here is housed in a tool that allows me to interact with the data. As you can see, it's quite a nice user-friendly tool, but it is also a data service, which means that any other system that wants to then work with students is able to work with this data as well through a set of RESTful services. So if you have people who are going to be developing custom apps, mobile apps, or you've got people who are going to be building websites or new components into websites, instead of cloning and creating another sprawl of student data, this is a really good place to come and home it, and everybody can use it. So in terms of starting off with the connected campus message in real life, students are a good place to start. And so we get them into the system. Then we do some really, really simple stuff as a starting point. We get their basic demographic information. Here you can see, wow, I'm not going to try and say that name, Zintler. You can see that this person is not currently in residence. And so already I've got a data point here that is something that I can use. They don't currently have a residence. If they were in one of your residences, we would then have tried to populate that. But this is an example of an augmented data. An example of how we would augment the data, and that's why this second point here is called augment the data. A couple of other things we've put in here, just in this simple screen, we've put their qualification in, so we can then use their qualification together with their routes to make certain inferences about how students are traveling within various specializations. We've got an email address, but here I think is the interesting piece for this particular solution. This is a real solution. Here you'll see this particular student has been categorized as a day student, but they've also been marked as special intervention. And so in this particular context, what this means is that this particular individual has been marked as somebody who requires meals for a reason that is not typically seen in financials. So in other words, I haven't purchased residence, and so I'm not entitled to meals 3 times a day. This may be because for whatever reason, this particular student has special needs and is struggling with low nutrition, or is in a low income bracket and can't afford meals. And so there may have been an intervention that's given that person the ability to be marked as special intervention. So what we do with this is we go and we say, well, now I'm going to use this data and I'm going to decide if and when this person can eat and where they can eat. So just as a starting point, some minor little extensions to a really basic profile, and we can start doing some cool stuff. So just by virtue of me knowing that this particular person is a day student who has special intervention needs, I can then start doing some stuff, and I'll show you what that is in a second. The next step is to collect what I've called transactional and real-time data. So what I've got here is an example of data that we've integrated with Salto. Salto is a fairly standard access control system. What we've done is we've allowed Salto to communicate with Dynamics in real time. So as this particular individual moves around in the university, we can see their movements and we can see which doors they're tapping on and all that kind of stuff. And we can see it in near real time. So we're getting access to the information within 2 or 3 seconds of each card tap. And that's what's building up this data set. So just in terms of this contact record, the summary tab, which you can see hidden a little bit here in the screenshot, is where I had that categorization data and the base profile data. Then I've just augmented that data with this transactional data so that I know where they're moving. And then the last thing is to then, and I've titled it Light Up the Automation. The last thing that we've done is access that automation layer and gone and done some cool stuff. So with this particular student, we've gone and looked at their special needs categorization, and we've used that data to drive a rules engine that determines where this person is allowed to eat. And so just in a simple data set, what we do is we go and say, well, because that student is marked as a day student, that is a special needs student, we're going to allow them to eat at a certain frequency and at a certain set of dining halls. And so you can see in this data, the system has automatically gone and determined that this person is allowed to eat dinner in dining hall E, allowed to eat breakfast in dining hall E, and each one of these records is a specific individual meal. And so the system is continuously able to monitor the conditions in data because we've brought that data into the platform, and it's constantly able to make real-time decisions as to whether or not to allow this person to eat. Now, this data set's quite a simple one. If you look at the columns, I know who the person is allowed to eat. I know that they're allowed to eat dinner. I know that they're allowed to eat dinner in dining hall E. This probably was determined because dining hall E is a default for people who don't have a home residence. And then this status I'll talk about in a minute. And if you just look peeking out the corner here is a date. And that's the date on which this person is allowed to eat this meal. So what we do with this, which is really cool, is because we're connected and we're using the platform that can speak backwards and forwards between systems, we go and say, because this person's allowed to eat dinner at dining hall E tomorrow, then when it comes dinner time at dining hall E, we dynamically open the gate for her at that particular time. And so she doesn't have access to that gate or that dining hall at any other time other than in the periods that we stipulate. And so just the ability to see what we should be issuing gives us the ability to control her access to the various dining halls. And we do it in real time, and we do it specifically between different windows. And there are some side effects of that I'm going to talk about in a second that I think start to develop quite a compelling value proposition. The last step is to connect the students. And so I've got an example of a mobile phone. This is an app that exists. Basically, what it allows students to do is we say, because you're allowed to eat meals at specific dining halls at specific times, and we can determine what those are based on rules that we can configure because we can see your data, we can spit out a schedule for you. And so from the end student's point of view, they get a meal management app and they get to select their meals. And so what you're looking at is a user who's logged into the app. The app has gone and looked at various data points. It's gone and determined when they can eat, and it's gone and generated entitlements. And so what you're looking at now is the system telling me, as the user who's logged in, that I'm allowed to eat on Monday and I can have breakfast and dinner. I'm allowed to eat on Tuesday and I can have breakfast and dinner. The next screen just shows me inside what it looks like when I turn those on. You'll actually see that I was entitled to eat breakfast, lunch, and dinner, but I hadn't elected to eat lunch because you can see I've expanded this Monday. Now, this is me collecting your preferences, right? That's what I referred to earlier, because here, our rules engine has determined that we always force this person to eat in dining hall 1 for breakfast. I see the labels are all wrong. These should say lunch and dinner. But these two switches over here would allow me to toggle between eating in hall 1 and eating in hall 2 for my lunch meal. And then obviously this one should say dinner, and it's a prescribed meal. So the student can then turn the meal off, turn the meal on, and then select a preferred dining hall for their midday meal. And so when it comes, I've been saying it a bunch of times as I've been going through the demo, there's a bunch of implications, a bunch of implications. One of the things that happens is now, because we're collecting in real time how students are accessing doors and lanes, and so we also know how they're accessing dining halls, there's a bunch of stuff that we can tell. And so what I'm going to do is I'm just going to end my screen share, and I'm going to share the actual model with you. So I just want to show you a couple of things that we can see just because students have generated two very simple data sets. We know whether or not they're in residence, and we know whether or not they're entitled to eat. And we've got a rules engine that can generate entitlements to eat, and we know their card taps. Those are the really basic data points. Just give me a sec. I'm just waiting for the model to load up on my side. All right, it is a real model, so it's just taking a few seconds to refresh. Here comes my screen. All right. Sean, can you confirm that you can see the model?
Got you.
Okay, cool. Right. So those simple data sets, just the ability to have looked at a student and realized what their card taps mean to us, and then looking at just one or two data points that we've been able to trawl from ITS, we've been able to make a whole plethora of decisions and show a whole bunch of stuff here that we can then monitor. So what you're looking at is a data set that is generated off of this scenario that I've been describing. And so you can see currently that we're servicing a surface area of 2,765 students. Of those 2,765, meals, 931 are breakfast, 1,360 are lunch, 474 are dinner. If you look down the bottom, you can see that we're able to profile the amount of traffic. I'm going to need to explain these in a little bit more detail over a time period. And so that's what we're looking at down the bottom. So what I'm going to do is I'm just going to squeeze the time period because it was for the whole of August all the way through to September. I'm just going to squeeze it a little bit. I'm going to squeeze it a little bit more. There we go. Just to clean up the data visualization. So now we're looking from the 9th of August to the 1st of September. You can see that my trends have updated, and at least what I wanted to do was I just want to get to the point where you can see the dates on the bottom. So if for argument's sake we were sitting here on August 21st, which it appears that this data set, this was the last time that this data set was updated. If I was sitting here, I would now be able to predict roughly how many students are still going to be coming through for meals. And so I can see that in data because the entitlements get pre-issued. So what I could then do, and this is where it starts to become quite cool, I could say, look, I've got a particular vendor in dining hall 1. So let me select that particular vendor. And I can already say to finance, look, for this period, we're only expecting 187 students to be entitled to eat in this particular dining hall over this period. 69 of those meals are breakfast, 91 of them are lunch, 27 of them are dinner. A whole bunch of them have been redeemed already, but I can then, in fairly granular detail, predict throughput at that particular dining hall. And so I can say to them, look, for the remainder of August, if we were sitting in August, this is how many meals you're expecting each day. And so that particular vendor then is able to thaw less food, waste less, prepare more, and the university is also able to control at a far more granular detail, at a far more granular level, how many meals they should be issuing in that particular time period and how many to expect. So you get both the ability to predict and manage operations as a result of just access control within the various dining halls, but you also get the ability to then control finances, right? And negotiate tighter contracts, different contracts, because you're able to see in real time what your actual consumption is and your forecasted consumption coming up in the future. And that was really just two basic data points that gave us the ability to do that. Another thing that we can see, and I'm just going to turn dining hall 1 off so that we're looking at the whole data set again. If you look at this thing, at these two here, you can see I've got breakfast, dinner, and lunch profiled on the timeline, and this side I've got booked, issued, and redeemed. So if I look at the redeemed line, which is this orangey brownie worm that is traveling here, you could see here that I am really only redeeming a peak of 21 meals. Now, redeemed is an actual card tap at a door, at a lane, in a meeting hall, in a meal hall, in a dining hall, between the times that that particular meal is open. So what we do is we open the door for the student for that particular meal, and if they go through and tap it, we redeem that particular meal in real time. So we also know in absolutely granular detail which meals students were entitled to and which meals they actually ate. And we know exactly where they ate those meals. And if you put lanes inside the dining halls, we'll even know which lane they used to redeem that particular meal. And so in real time, you get to see that. Now, here's where it starts to get interesting. If I'm only redeeming 20 meals and I have a total here, you can see here I'm expecting, let's just go to that same day. Let's go to the 19th. There's 21 meals that were redeemed, but on the 19th, on this side, you can see there were 32 meals that were eligible for eating in total. So there, if I add those up, that's roughly, what's that, 60-ish. So roughly 60 meals is what we would have been eligible to produce and force and make available, when in real life only 21 were consumed. And so it gives us the ability in real time to control consumption and our conversations with our vendors. So it's quite a cool data set. The other thing that I just wanted to point out, and then I'll be done, is you can also say if you had different vendors in different dining halls, you would be able to say which ones are more popular. So in this one, you can clearly see people are eating lunch. That's the most popular meal by far. And if I did that, I would then be able to say, look, for the most part, they're eating that lunch in dining hall 2 and 3. 1 and 4 are getting marginal traffic by comparison. And so there's a bunch of different stuff that you can see just from a basic transactional data set that's honed in a platform. And so that is pretty much what I've got. If anybody else wants me to dig around in this data set more, I'm happy to do it. But I think swings and roundabouts, I've given you an idea of what something as simple as transactional data from access control and a really basic interaction with ITS gives me the ability to do a whole bunch of stuff. And I think this is just an example of the underlying value proposition that is inherent in this connected campus message. Cool. I think, Sean, over to you.